Alrighty, Pines at Mines and Wines. You'll see there that there's a MinEx CSC badge. I was fortunate enough to pick up a scholarship with MinEx CSC a few years ago, and that's been, well, it's provided tremendous support and funding for this project. With MinEx CSC, we have a whole bunch of sponsors, you can see there. Also, we've got a whole lot of research participants and affiliates. And in particular for my project, these results would not have been possible without the tremendous support from Aurelia, and in particular Adam McKinnon during his tenure at Aurelia, Michael Oates during his tenure with Peel, and also the Geological Survey of New South Wales, who got behind this in a big way. Also during their tenure, John Greenfield, Chris Yates, Phil Gilmore, and the rest of the staff here have got right behind this project and supported it, not just with the MinEx CRC PhD scholarship, but ongoing funding for a couple of the tree dissections we're going to look at today, some soil sampling and seasonal sampling. So without all these other companies, today's results wouldn't mean much because we've needed access to the deposits. Also, a lot of support and help from Olympus trying to sort of tweak the use of the portable XRF for vegetation, and also Lab West have been tremendous. So the project aims were first to establish what the regional background was for Cypress pines, so we've got an understanding of what the chemistry is that they are taking up out of the soil, and then comparing that with mineralised signatures at the deposits and prospects across the Cobar Basin where we've been able to get access to. And the basis for statistically separating them, but as you'll see, we don't even need any statistics to separate themselves. They're doing a pretty good job themselves. Secondly, it's important that it becomes an efficient and sort of cost-effective method, and one of the ways we've been looking at is how to incorporate the use of the field portable in the field, and no, that's not how you use the XRF, just in case. That's very unsafe, but just using it as a description to catch your attention. And thirdly, what controls are the cypress pines got on the uptake of on metals? And what implications does that have for interpreting the results? So you can see that this project fit in with MinEx C in their sort of Program 3, Project 9. So it's targeting mineral systems in covered terrains. We're relying on the roots to get through the, hopefully some of that transported cover into the deeper profile, and targeting the elements that might be shedding off mineral deposits. So what are cypress pines? They're part of the conifer family, so there's about 588 worldwide. They evolved through Europe and North America about 310 million years ago, and about 65 to 70 million years in Australia. They have simple needle-like kind of leaves, which we call phyllodes. They're seed plants. They've got hard woody cones that split when they dry and release the seeds. We have 13 native to Australia and 3 to New Caledonia. The species that we're mostly focused on or dominate out in the Cobar Basin are the Calitris glaucophylla. And if you do a search online, you'll be able to see that the distribution comes up like that across the eastern seaboard. So there's plenty of scope outside the Cobar Basin and not just where my project area sits there. There's a bit of conjecture with the nomenclature in the botanical field there. I stick with Calitris glaucophylla, sometimes synonymous with Columularis, but glaucophylla is easier to pronounce, so I stick with that one. We've got some other species out there. On a rare occasion, you might see an Endlicheri, but they're easy to pick. So 99.9% of the time, it's Calitris glaucophylla, so there's not going to be an issue with identifying the species. What do they typically look like? That first picture there was taken during drought period, nice and easy to sample and walk around. It's a little bit jaded in its colour because it's lacking a bit of moisture. The one on the far right there, you can see it's a nice vibrant green, and that's what they generally look like when they've got a lot of rainfall around. The classic sort of Christmas tree shape. When they get really big at about sort of 10 to 15 metres range, they're generally growing over ground with more soil cover than shallow subcrop. And that's what Endlicheri looks like. It's a nice bright green, they're easy to pick, and the needles look slightly different. And when you grind them up in a coffee grinder, they've got a different aroma, so straight away you know it's a different species. In terms of the project area, if you go onto MinView, This is the research question that's sort of been answered here. The field of biogeochemistry has probably been ignored for too long. So those 3 yellow dots is all that comes up on MinView if you look at the government's online data portal. Some saltbush out at Broken Hill, some prior pines in the Cobar Basin there, and some stuff out at Bathurst. I've tinkered around with pines in the past, but and a few other people have. I've covered that in a previous presentation. But nothing really substantial other than my supervisor's study up in the New England region in 1998, but that hasn't seen the light of day for 20 years. So that will hopefully come up onto MinView. So that was a multimedia, multi-species program, so hopefully that will be available for everybody. The project area covers about 42,000 square kilometres, and it's mostly dominated by the roadside sampling. So that was the early stages of my PhD or research sampling before I got access to all the deposits and prospects. So it covers about 5% of New South Wales. So we've got regional samples along the roadsides. I've accessed a lot of deposits and prospects. We've done seasonal sampling, a couple of tree dissections we're going to look at next, and of course some dust studies. I got caught in that dust storm out at Cobar a few years ago, and you start to wonder how much of an impact is that going to make on the cypress pines. In terms of country size, it's comparable. The area that I've covered is comparable just to the size of Switzerland. So it's a fairly substantial sort of area to cover. Now the approach, this is the best diagram I've found to sort of explain the approach of biogeochemistry. We've got a mineral system buried below the surface, and as that weathers over time and we start shedding off that high concentration of metals, both laterally and vertically, and that's assisted, maybe it's come up along faults that have broken up the deposit. Roots can then grow down those faults as well. You've got water table moving up and down over time, and those elements are being dispersed to the surface. We've got the tree roots growing down, hopefully through a thin cover, getting away from that foreign kind of wind-blown component and the ferrocretes and the pisolites and the maghemite there. So those trees grow down, and as those elements migrate up, interact with the soil bacteria, that makes a lot of these elements bioavailable to the trees through the root system. Then we come along and we sample the trees and we send that off to the lab. Now, we're going to look at a few elements at a couple of trees we dissected at the Hera mine site, thanks to the support of the Geological Survey of New South Wales, who funded this research. We took, I need the laser. We got something here? No. Okay, over on the eastern side there, we have the background tree just east of the mine village. That's growing out in the flat area, so it's a much larger tree. It's got a thicker soil profile. The high-grade tree we took from the silicified outcrop there is that circular sort of grey shade just northwest of the surface mine infrastructure. We knew what we'd sampled these trees already, so we knew what their grades were before we dissected them. We also did a lot of dust control sampling to the north of Hera there, to the north-east, and also a lot of sampling across to west, because that's where Hera North Pod and other stacked faults and mineralisation sits. So we got a lot of high-grade results at Hera. These were the tree dissections. So that high-grade trees growing on the side of a hill on the left there, so it's eking out a living on very thin skeletal soils. We've got our background tree, as you can see, is out in the flatter area, so it's got a much thicker soil profile, it's growing higher, it's got its probably roots deeper down into the system. So we chopped those down at regular intervals. We took 8 fractions off the tree plus the pine needles. So we did the hardwood in the centre, the outer wood, the cambium, which is just sits below the bark layer. We did the bark. We went along the branches and took 4 fractions there defined as twigs, and the pine needles themselves. Now if we look at copper here, we've got height on the left-hand axis, we've got parts per million on the bottom. We've got the legend there on the right, so the black and greys are the trunk material, the blues are the outer bark and cambium, the twigs are those beige dots, beige-brown, and finally we've got the needles in green. So in our background tree, you can see that the copper Doesn't vary much from top to bottom in the tree, in the green needles there. There's almost more in parts of the twigs. It's a highly controlled metal due to its phytotoxicity, so the tree's trying to restrict as much as it can, and it looks like it's dispersing of some of that excess copper into the upper outer bark layer, so it's just pushing it as far away to the outside of the tree as possible. And the same trend you can see in the high-grade tree, except that we've just got higher contents because we're in a mineralised zone on a silicified hill close to the Hera deposit. So there's that trend of disposing that excess bark away from itself as far as it can get. Another element that's probably the most fascinating plot we've got for the tree dissections is what it's doing with magnesium. On that bottom left, we can see that, or for both the high grade and the low grade trees, we can see that for all other organs except the pine needles in green there, it's controlling its uptake of magnesium to about, it seems like some magic number of about 1,000 ppm. So all of the other tree organs are getting their budget of magnesium. All the excess is off to the pine needles. And why might that be? Well, magnesium is a key element in chlorophyll. Chlorophyll is important in photosynthesis. That happens in the foliage. So that's where the magnesium is being dispatched to. Now, a couple of elements that we're probably more interested in is lead and gold in terms of exploration and vectoring towards mineralisation. With our background tree there on the top left, we can see that there's a bit of a spread of the data. There's a bit of a trend to the outer bark. Lead in plants, in the cypress plants, or most plants in general, they use some of it in the cell walls, but there's not much other use for it. It can be toxic. So some of it's being shed to the bark in those light blue triangles. In both trees you can see that. But the real kick is when we get a response to mineralisation. In the background tree, it's got a few parts per million there. We're at the Hera mine site, so the local background is much higher than what the regional background is already. But when we've got very high amounts of lead, you can see the contrast there, that the high-grade trees are separating themselves in the needles away from all the other organs. So that makes lead one of the key elements that I look for, or we look for, using biogeochem in the cypress pines. Same thing's happening with gold. There's a nice trend there on the bottom left. The local background here is still well above the regional by about 3 to 4 times. Normally only a half ppb gold. We've got about 1 to 2. That's because, as I said, the Hera zone is saturated in above average geochem in the pines. However, when we look at our high-grade tree, like the lead, we're seeing a massive uptake of gold. So that's 15 to 45 ppb. So these are not small anomalies that we're looking at in terms of contrast. If we just look at what's happening regionally, I did a lot of regional sampling for the last 4 or 5 years along the roadsides. If we look at zinc across the Cobar basin here, and we've used sort of a modified version of Vlad David's geology that suits this presentation, we can see that zinc looks like it's being generally well controlled in its uptake across the whole basin. Doesn't matter what the underlying geology is. It's kind of like copper, but zinc will respond when you get high-grade zinc in the area. If we look at manganese, the Giralambones out on the east are taking up a lot more than the deeper sediments and volcanics and intrusives on the western side. There's a lot of work to go to pull apart the basin for all these regional traverses, so these may have to be just separated on long sections to get the best out of this data. So there's still a lot of work to go in interpreting the regional stuff. All the sexy stuff is with the mine sites. If we look at Federation, we just heard the history there. At Federation, we were lucky. The IP survey was run in June, or just before we got on. So we did a orientation survey along that top line. Then we headed down south across the outcrop, which is that dotted line. We went down the bottom, picked up another IP or another line that cut Dominion, and then we split up. I went up north on the side. My supervisor did that diagonal transect. And straight away when we got the ICP results back, they're sitting over the 2012, I think, soils by YTC. You can see that they got a much broader anomaly. The pines picked up a much more discrete anomaly, and that discrete anomaly sits right over the centre of the high-grade zone for lead. Another good response from Dominion. So we've got two different mineralisations. So we've got deeper at Federation, and we've got the shallow response coming from Dominion where the gossan outcrops at surface. If we compare the contrast with background at Mallee Bull as well, we've got that Mallee Bull sort of northwest zone trend through there. The pines picked up that zone very well, and a good contrast with away with those background traverses. We also picked up some stuff north of Mallee Bull, and just speaking to Seb before, he said it's still open to the north. We got historical workings to the south, we picked those up, and it's still open to the south. So the pines are really picking up that mineralised trend well. And it doesn't seem to matter what the absolute number is, we're getting a nice contrast. If we put that into a cross-section at Federation, this is what it looks like. That's the resource from last year. And we can see that the peak of those lead numbers sit right above the Federation resource. And that's the gossan out at Dominion. When you XRF that, that's about 50% iron, 1.4% lead. So those trees at Dominion there, you see a much stronger concentrated result, and that's because they're growing literally right off the top of the gossan. The surprise element has been tungsten, both at Federation and Mallee Bull. I lost my IP underneath, that's not good. Anyway, you can see that response there at where Federation is, and you can see the response at Dominion. So both of those sit within the IP responses that we saw in the previous presentation by Owen. And also at Mallee Bull, we can see a really nice contrast with the background there. So we get a good response over that Mallee Bull trend, and it just drops right off once you step off that footprint, that mineralised zone. That's what tungsten looks like in cross-section over Federation and Dominion. We can see that we get a really good kick-up over those two zones. And just coming back to copper, no contrast at all. We can see that it's fairly consistent uptake. We do see a little bit of a kick there at Dominion. That's about as subtle as it gets at times. The copper story's not over. I've recently sampled a couple of other copper prospects, and we are seeing a bit of a kick, I guess, when it's got so much copper in the ground and it's forced to take up that groundwater moisture. It will take up some extra copper, but generally it's very, very consistent uptake. And the same for Mallee Bull, so we don't get really much of a contrast here. Just looking at a few analytical comparisons, at the Miandetta sort of nickel ultramafic prospect, we did some work there recently and discovered that the pines really like nickel for some reason. Not sure why, but they're taking up a lot of nickel if it's available. On the left there, we've got the nickel response in pine needles, and we're getting up to 180 ppm nickel in pines. So that's an extraordinary number. We didn't think we'd get anything near that. That's about 100 times the regional background, which allows a really good contrast. We XRF'd both the needles there in the top and the soil, so you can see that we're getting coincident anomalies at both sites. Now, when we plot on the bottom there the XRF that we've done in the lab, so we've taken the needles home, dried them, powdered them, macerated them in, put them into a Ziploc bag, and we've zapped them, we get a really good correlation with the same sample that we've sent off to the lab. And likewise, the next step in this process has been analysing the pine needles out in the field. So we've got the ones that we've dried ourselves, macerated in the lab, and then we go out and we sample the same tree again, but this time we analyse the needles straight in the bag with a portable XRF, and we're still getting a reasonable correlation. Now, when you sample them in the bag, you've still got a lot of space when you put your XRF in there, so there's a lot of airspace still. There's a moisture content that you lose of about 30 to 40% when you dry them, but we're still getting enough of a response that we can have confidence in. And more importantly, the choice element is lead, and we can see that our ICP-MS lab results correlate exceptionally well with a portable XRF. Most of the data above 40 ppm is insignificant, because once we get to 40, we're already at 100 times background. So when I'm out in the field, even if I get 1 ppm lead with the XRF, that's already 2 to 3 times background, and that starts to become significant. So that gives me a lot of confidence when I see that correlation between using the XRF in the field. Even though it's not designed for biogeochemistry, we're using a soil mode with the Olympus Vantel. So it's horses for courses. It depends what kind of unit you got, what mode you're setting in. But I've put down a little table here in the bottom left, so just a guide. The key elements that if you're using field portable, the average numbers are there for those elements, the limit of detection, which is just a guide. For lead, you will still get responses below 5, which I trust those numbers because they come back from the lab and they correlate very well. And it's important, as soon as you get a lead anomaly with the biogeochem and the Cypress pines, you've got to follow up. So I start infilling straight away. I tighten up my spacing, and I'm looking for a tight cluster of trees that are responding to lead that might indicate this is the footprint. I'm sitting above the footprint of a deposit or a prospect or some form of mineralisation. Maybe economic, may not be. The final column there is the contrast. So that the pines are taking up to 100 times their regional background. We don't know what the upper threshold is, because every time we go to a different area, it sort of sheds new light on their potential, on their uptake. So gold won't read, as we know, so generally it's about 0.4 ppb on average for gold. So anything above that, everything above 1 ppb starts to become interesting. All right, in conclusion, after 65 million years, the cypress pines are finally revealing their secrets. They look like they're absolute metal hounds. They love the elements as much as we do, so they're providing excellent contrast and vectoring. It looks like lead and tungsten are the two superior elements to use. The benefit with lead is we can use the portable XRF in the field for that one. And these may turn out to be some regional ore finders in the Cobar Basin and maybe elsewhere. There's a lot of scope for expanding biogeochem, not east of Cobar, north and possibly south. So the only element that we keep an eye on is copper, because it's highly controlled in its uptake due to its phytotoxicity. You might consider needles as an alternative to soils, depending on what area you're in and what confidence you have in the soils and the thickness of the cover and the transported material. The pisolites, they're a bit of a problem. You will see a kick up in the iron an iron manganese when you're sampling over the paleo channels. The portable XRF, when you're sampling, you can turn over a tree site in about 5 minutes. If you're doing sort of prospect scale sampling, normally we're at about 50 to 100 metres in terms of spacing. You might tighten up to 25 if you start to get something interesting. It's cost effective in the field. You can get some anomalies straight away, and you've got a suite of elements there that you can keep an eye on, particularly lead. The labs now are fantastic with the trace elements, so we can see things like tungsten. Rhenium's also an interesting one to keep an eye out for. That's responding over some of those mineralised systems, and if you look at the poster over there, you'll see rhenium for mallee ball. So yeah, the game changer has been being able to use the portable XRF in the field, so we can get an understanding straight away of what might look interesting. So if you jump over to the poster over there, there's a lot of complementary stuff that goes with this presentation. There's a few links there to former presentations. Hopefully have this wound up in the next 12 to 18 months, and then all this data will be available in MinView. So those of you that want to undertake some biogeochem work, you'll have a huge data set that you can benchmark your results against. So when you're out in the field, all you project geos, this is what you should be seeing when you look at a cypress pine. And those are the elements under there that are going to work well for you, that are coming up through the root system. And keep an eye on for copper, because we are getting some indications that where there's enough copper in the system, that the trees will take it up whether they like it or not. So that story is yet to unfold. I'll leave it there. I've got to, once again, thanks to all those companies that have been open-minded about the research and supported it and opened their wallets, more importantly. And my two supervisors, especially Dave Cohen, a lot of help out in the presentation today. And please come and chat to us if you've got any further questions. Thank you very much.